एवरीवन, अभी हमारे पास जो क्वेश्चन है ये TIFR GS 2025 से है. Let us see what is the question trying to ask. यहाँ पर the question says that let Qn be the enumeration of all rationals. As Q is a countable set, हम इसको it can be written in the form of some enumeration of all rationals such that n belongs to n difference 0. And Qn is not equals to Qn if m not equals to n. They mean to say that इस सेट में जितने भी एलिमेंट्स हैं वो सारे डिस्टिंक्ट हैं. एंड हमको एक सेट x दिया गया है which is the union n equals to 1 to infinity Qn minus 1 by n square Qn plus 1 by n square. This is the interval what we have. And here हमको एक करेक्ट ऑप्शन चूज करना है. So, हमारे पास जो options है, the first option is x is dense in R, but it is not equal to R. The second option is x is equal to R. The third option is x contains an open interval of length 10. So, basically हमको ये तीन options given है. चौथा option है अगर ये तीनों सही नहीं हुआ तो we go to the fourth option. तो basically हमको ये देखना है that is the set x a dense subset in R or not. सबसे पहले हम इस बात को सॉर्ट आउट कर लेते हैं, then we will go to the next. अभी ये सेट X में सारे रेशनल्स बैठा हुआ है. The set Q is the subset of X. We can observe that. क्योंकि अभी जो इंटरवल है Qn minus 1 by n square, Qn plus 1 by n square. If this is the element Qn, this is Qn minus 1 by n square and this is Qn plus 1 by n square. तो सारे जो elements Qn है, these set the collection of all elements Qn, n belongs to n difference 0. This is a subset of X. ये सारे जो individual elements है, that is a subset of X, and this is nothing but the set of all rational numbers. अभी and anyways, this set X, this is the again the subset of the set of all real numbers. And हम point से topology से जानते हैं that if A is the subset of B, then A closure is the subset of B closure. तो हमारे पास है Q is the subset of X and this is again the subset of all real numbers. So Q का closure जो है, this is the subset of X and this is the subset of R ka closure and here this is X ka closure. So from here we have R is the subset of X ka closure and this is the subset of R. So from here we have X ka closure is equals to R. So यहाँ से एक बात तो प्रूव हो गया that जो set X हमको given है that is a dense subset of R. And here what is the basic result we have used? That if A is a subset of B, A closure is a subset of B का closure. अभी X is dense in R, ये बात तो सही हो गया. But is it equal to R? That is the next question what we are going to address. So, abhi the set X, this is nothing but union of n equals to 1 to infinity, Qn minus 1 by n square, Qn plus 1 by n square. Where this set Qn is the enumeration of the set of all rational numbers. This is the information what we. अगर मैं इस सेट का मेजर निकालूं, so what is the measure of this set X? The measure of this set X, this is less than equals to summation n equals to 1 to infinity, measure of this interval Qn minus 1 by n square, Qn plus 1 by n square. And why are we able to write this? We are able to write this because the property of the countable subadditivity of measure इस प्रॉपर्टी की वजह से हम ये लिख पा रहे हैं. एंड दिस प्रॉपर्टी सेज दैट कि अगर मैं एक कोई भी एक सेट ए को सम काउंटेबल यूनियन में लिख पा रही हूँ, then the measure of this set A is less than equals to summation n equals to 1 to infinity measure of the set Bn. This is the property what we are using here. And ऊपर से ये सारे Bn's disjoint हुए तो ये इक्वालिटी में बदल जाएगा. So, but we are bothered, least bothered अगर वो disjoint हो रहे हैं या नहीं, we are least bothered about that for now. तो ये हमारा लिख सकते हैं. एंड व्हाट इज द मेजर ऑफ एन इंटरवल? अगर मेरे पास कोई भी एक इंटरवल है a comma b, then the measure of I is nothing but b minus of a, right? So यहाँ पर using these two concepts हम लिख सकते हैं the measure of the set x is less than equals to summation n equals to 1 to infinity measure of this interval. Measure of this interval, you just take this element to be a and take this element to be b. So it is a b minus a. So qn plus 1 by n square minus of qn plus 1 by n square. So qn cancel हो गया and this is equals to summation n equals to 1 to infinity 2 by n square. And हम जानते हैं that summation of 1 by n square वो equals to pi square by 6 है. तो measure of the set x is less than equals to 2 times of pi square by 6, which is nothing but pi square by 3. So the measure of the set x which is given to us, it is always less than equals to pi square by 3. So can the set x be equal to r? अगर set x equal to r हुआ, if, then their measures should also be the same. That should be infinite क्योंकि measure of the set r is infinity. But here we are getting the measure of x to be a finite number. So definitely the set x is not equals to. So from here itself we conclude on option A that x is dense in R, that is true, but at the same time it is not equals to R. So option A is the correct answer. But still, as we are practicing here, let us have a look to the other options as well. अभी x equals to r है? No. x contains an open interval of length 10. अच्छा, तो हमको बोला जा रहा है that x contains an open interval of the length 10. So again, यहीं पर फिर से measure का concept use होगा. Let us say that the set x has an open interval of length 10. अगर length of this open interval अगर 10 है and मान ले that I is the subset of x. मान ले कि एक ऐसा open interval है जिसका measure 10 है and that is a subset of x. Then by monotonicity of the measure, we have measure of I is less than equals to measure of x. So measure of I is 10. This is less than equals to measure of x, which is less than equals to pi square by 3. 10 less than pi square by 3. Definitely it is not possible. Pi square का value somewhere 9 point कुछ होगा and it is we are dividing by 3. So ये pi square का by 3 का value कुछ 3 point कुछ होगा and 10 is less than that and this is a contradiction. So इसीलिए we have option C to be also the wrong option. So option A is the correct answer. Hope the solution is enjoyable. Thank you.